A lot of people and businesses approach building AI systems like this. They say, let's build an AI agent or let's use AI. Many people are caught up in the hype around AI and they start with particular tools. That sometimes works, but it often produces really bad results. So here's the truth: the difference between building systems that often fail and building systems that reliably work, even in production under difficult circumstances, is a disciplined process. So, in this video, I'm going to walk you through the process that serious AI engineers use to build real AI systems. So, before we jump into the process itself, let's very quickly review why this is so important and why you need a process. If you're trying to build an AI system without a process, there are a variety of things that can go wrong. You can build the wrong thing, you can use the wrong architecture or the wrong algorithm, you can waste a lot of time and resources, or you can end up building something that often fails or breaks in production. But with a process, you get faster iteration, faster completion times, more reliable systems, and ultimately better business results. AI engineering is ultimately about structured problem solving, and this process is going to give you a structure for solving your problems. Okay, let's jump in with step one. Step one, you're going to understand the problem and define the task. Here, you're just trying to figure out what business problem you need to solve or what task you need a system to accomplish. Now, speaking very generally, and I've talked about this in past videos, there are a variety of different task types generally in AI and machine learning. There's things like generating text, classification systems that classify inputs into categories like one and zero, yes and no, spam or not spam. Those are classification systems. There are systems that act more like predictive systems that are predicting something in the future. And now, with certain types of AI agents and AI driven workflows, you can do a lot of workflow automation and process automation inside of a business. So, those are generally types of tasks, but then there are types of problems that are being solved. And this is key. At this step, you're trying to understand from a business perspective what problem you're trying to solve. Do you need to automate a particular workflow in a business? Do you need to decrease churn? Are you trying to increase revenue? And if you dig a little bit deeper into the revenue question, it might mean increasing the number of purchases that a customer makes. It might mean customer acquisition, and so on. Those are a couple of high level examples from a business perspective. And some of those are a little bit more marketing or sales oriented. But my point here is that you need to understand the business problem that you're trying to solve. Next, you need to scope the problem. So after you understand the business problem and the type of task that you're trying to do, you need to try and scope it. Try and figure out a little more detail. What exactly does success look like? What key metrics will you use to measure system performance? What sorts of data resources do you currently have? What sorts of human resources, meaning AI engineers and technology professionals, who do you have on your team that might be able to work on this? In this step, you need to try and understand your constraints. How much money are you going to have to work with? What sorts of latency requirements do you have? How much can you spend not only to build it, but also to run the system over time? You're just trying to get some constraints and parameters that allow you to define the problem even further. You don't need to get all of the details perfectly correct at this phase, but you are trying to get more information about the potential success metrics, resources, and constraints for the project. Keep in mind as well that you often cannot do this strictly with an AI engineering team. You're often going to need to talk to multiple different people. So that's going to include AI engineers, potentially DevOps people or software engineers. That almost always includes a subject matter expert, and it's probably going to include business management or business stakeholders as well. So make sure that you're including those people in your scoping conversations. Next, once you understand the problem that you need to solve and you have a little more detail around the constraints and the scope, you want to try and brainstorm several different approaches. The reason for this is that there are typically many different ways to solve a given problem, and they're going to have different pros and cons. So, this could be a simple LLM system that accepts a prompt and returns an answer. This could include a RAG system. It might mean an AI agent. It could mean classic machine learning. Instead of using a modern LLM, you might want to use a classic classifier. Depending on the exact problem and depending on the constraints, classic machine learning in some cases can work quite a bit better. And it might also mean not using AI at all. In some cases, just using a traditional deterministic computer program or script can solve a problem, or you might choose some sort of hybrid approach that involves many of the components that I just mentioned. So you're going to brainstorm a variety of different solution types. One thing that I'll note here is good judgment and some experience can really come in handy here. It helps to understand what types of architectures and algorithms are best for solving different types of problems. And it can be very helpful to understand the trade offs of different architectures and algorithms. Things like cost versus performance, speed versus accuracy, and so on. Next, you'll experiment. Here, you typically want to pick your best 1 to 3 ideas and you're going to try and build a prototype. Now, sometimes you're not going to have enough time and money and resources to build 3 different prototypes. In that case, maybe it's only 1 or 2, but you're going to pick your best ideas and try and build a small prototype. And here, what you're trying to do is you're trying to get more information about the problem and the likelihood of success. So you're trying to get more information on how hard it's going to be to solve the problem with a particular approach, with a particular architecture or algorithm. So you're trying to get a sense of how hard it's going to be, what the difficulty level is with your different approaches, what the costs are ultimately likely to be. After you dig in, you're going to get a much better sense of that, as well as the likelihood of success with a given approach. So here, ultimately, what you're trying to do is you're trying to figure out 2 things. What's the cost and difficulty? And what's the success or the return on investment for your candidate approaches? A couple of points here. Don't overbuild early. It can be sometimes easy to get pulled in a little bit and you build this thing and then you try and add one more thing and add one more thing. And pretty soon you're spending maybe too much time on it. So avoid overbuilding early. Also, to kind of reinforce this, you're really using this experimental step to get more information on what's likely to work, and you're trying to do this in a relatively cheap and fast way. At the end of this experimental phase, you're going to review all of your experiments with your team. That is going to include, again, your AI engineers, maybe some other technology partners like DevOps people, but it's almost certainly also going to include the subject matter expert, your executives or executive team, and the business stakeholders. Collectively, you're going to review the results of the experiments and collectively select the approach that you think is going to be best for solving the problem. Next, after you've selected your best approach, you build. This is going to include all of the gritty details of building a serious system, getting your data right, building your data pipelines, cleaning up your data. For better or worse, data preparation is still an enormous part of AI and machine learning, just like it is with classic machine learning and data science. This will include building your systems, maybe your vector databases and your RAG systems if those don't exist yet and you need them as part of your system, connecting to your external data sources, maybe connecting to other systems via APIs, building input-output handling, building some basic eval mechanics and eval systems, and so on. So this is the step where you start taking it from an idea or a prototype and building it into a serious, hardened system. Next, after you've built your first version of the main system, then you're going to evaluate. What you're trying to do is you're trying to figure out if and how well it solves the initial problem. You're trying to also identify any potential failure modes that the system is experiencing. So here you're trying to evaluate it on your metrics. Does it work? Does it increase revenue the way it's supposed to if you're building a system that needs to increase revenue? Does it do the thing that it's supposed to do reliably? Is it accurate? Does it perform precisely and at high quality? How well does it handle edge cases? And under what conditions does the system begin to break down or fail? I've talked about failure modes in previous videos. This is really where you're trying to identify those things. So do you have poor system performance, particularly on your key metrics? Is the system hallucinating? Is it brittle? Does it have excessive latency or high inference cost? Now, this is really important and it's a key point. I've actually talked to a lot of businesses recently that have AI systems kind of built, but they are not doing evals. They have systems in production and they're not doing system evaluation. They don't have test cases. They aren't doing traces and logging. They aren't measuring their system performance with metrics. They don't understand their latency or their costs. And these are multi-million dollar businesses. So you need to be careful. You need to evaluate. Otherwise, you're just kind of guessing. Finally, you deploy. This is where you launch the system and put it into real use. So here you're going to be getting real users using the product, using the AI system or features. You're going to have real data and real volume. This will enable you to do even more evaluation and monitoring once you're getting that real and real-time data. So here you're going to continue to monitor system performance, watch out for the major failure modes, and monitor things like cost and latency in a real production environment. I'll also point out that systems still often break here. That is normal. Just identify the problems, iterate, and harden the system over time. One important meta point here, this is often not a straight line. It's often sort of a loop. So you might get 1 or 2 or 3 steps, maybe even 5 steps into the process and realize that you need to go backwards. So maybe you start building some of your experiments, your prototypes, and you realize that you didn't define the problem correctly or you didn't identify the right key metrics. You might need to go back to step 1. You might even go all the way to some of the further steps and have to still go backwards. That is normal. Ideally, you do want to go as straightforward through the process as you possibly can. But in practice, AI engineering is often an iterative process under constraints. And it's also important to remember that this is where technical skill meets real business application. So you can be very technically skilled and very technically adept, but in order to build systems that solve real business problems and drive business value, you need to master this process.